notes I'd like to give you. We are doing a buffer lab today. We're going to split it up, probably have each of you do your own thing. So, and then 4 of you share data. So you're going to work together, but you're all going to do one titration, so that we don't have to all do 4. Does that make sense? The buffer. Yeah, but you're just using a buffer instead. And so you're either titrating with NaOH or you're titrating with HCl to see how much a buffer will hold. Okay, so that's what's going on there. The test is open, so anytime you're feeling ready to go, take that test. You can take that test up until Wednesday next week. I just have a little bit more notes I'd like to give you before we head back there and talk to you just a little bit more about that before we divide up. So just remember that you have a few things that need to be done before then. Okay, watch out for sapling and get your pretest done. Retake your quizzes before the 28th. The 28th is the last day you can take the test. So a couple things I thought might help you is when the titrations are here, I did find something. If you balance an equation, you can use the coefficients to put in front of this. So in front of whatever the hydrogen is, you can put it in front of here, and whatever the hydroxide one is, you can put it in front here to still use the M1V1 kind of version to make it quick. Instead of stopping and going from molarity to moles to moles to moles back to molarity, you can do it this way. Okay, so if you want to write that down, you can. It is a neutralization, meaning your hydroxides and your hydrogens have to be equal. So it's just a take on what we did up here, but this number of hydroxide and hydrogens doesn't refer to how many is in the compound, but the number in front of a balanced equation. Okay, so the number in front of a balanced equation. So if they have ones in front of them, you can just drop that out and you can use MAVA equals MBVB. But if they have a number in front of the balanced equation, for the acid, you would put that on the acid side. For the base, you would put that on the base side. Does that make sense? Okay. So if I'm looking, I'm just going to do a real quick equation right here. If I'm looking at NaOH plus H2SO4 going to Na2SO4 plus water, when I went to balance that, I would have a 2 right here and a 2 right here. So this number right here would be my number of hydroxide. So I would have put a 2 here. The number here would go here, which would have been a 1. Does that make sense? Okay, so you can do it that way. Just another way to look at it. Right, so I wanted to make sure I threw that out at you. And this one I just did that equation so that we could go through and do an equation real fast with that. So remember that as you go through a story problem kind of thing, titration, make sure you're pulling things out. I always like to write the equation first so that I know if it's a 1-to-1 or if it's 2-to-1 or whatever I need to do with it. So I'd write the equation out, and then I like to, underneath each one, write what it is. So this one I would need the MA, I would need the VA to put in the equation. This one I would need the MB, I would need the VB to put in the equation. So as I'm going through my story problem, I can say, okay, what do I need? It says, what is the molarity of? So the acid. I don't know what that is, so I'm going to put my question mark. That's my X. If this much of this NaOH, so both of those are NaOH, so I tie them here, 0.32 molar and 43.35, that's a 5 milliliters, to neutralize 25.9 milliliters. So now that I've got it organized, I can really quickly put it into the equation. And since it's got a ratio there, I'm going to rewrite here number of H, MA, VA equals number of hydroxides, MB, VB. I'm going to just plug in. So in front of the H, there's a 1. I really don't have to write the 1, but I'm going to write it for you guys. MA, I'm going to call my X, and VA is my 25.9 milliliters, is equal to, what's in front of my OH is a 2, times my MB, which is 0.32 molar, times my VB, which is 43.35 milliliters. Okay, at this point, basically one I can ignore, right? And I'm going to divide both sides by the 25.5 milliliters. Over here, the milliliters will cancel. Over here, just the mLs cancel. And then we can just plug it through, and this gets me my MA. Somebody's got a calculator quick and throw that through for us. We'll get an answer. You'll need one, yeah. We'll need one for the titration. Okay, has anybody got an answer? Yeah. So we'll take 3 sig figs, and that would be molarity of H2SO4. So we can really quick get the answer there. Sorry, my pen is doing the dot thing again at the bottom. Oh, and I already had this done for you. Okay, well, yeah. Okay, so there is a learning check that we can do real quick if you want to try it. I do have the answers up there for you. Some things that you'll need to know on the test. So you can do one just like I did. Hydrochloric acid, what is the formula? HCl. So you're going to write the equation first so you know what you're going to need. Or you can look at it and say, okay, HCl, and I have BaOH2. That means I'm going to need twice as much HCl, right? To balance it out. So there's going to be a 2 in front of the HCl. But you can go ahead and write the equation out and do like what I just did. And does anybody remember what amphoteric means? It can act as an acid or a base. So it can act either way, depending on who it's with. Yep. And then what makes a buffer, because that's what we're working on today. So really quick, take a few seconds, answer these 3 questions and see how you do. You can just put them anywhere on a piece of paper. That's great. What did I miss? Oh, Aisha is still in the bathroom. Okay. You are actually right there. So you're one away from where you're supposed to be. Okay, how we doing? We about ready to check, or we need a few more minutes? I'm not doing it, so I don't know how long it takes. How many have been able to do the first one? Okay, I'm going to go ahead and give you the answer to the first one, and we'll go do the second and third, just as a quick review. So you should have been able to really quickly notice that you needed twice as much acid as you did base, because HCl is your acid, so you need 2 H's to go with 2 OH's. That's the easiest way to remember it. Okay, and then you only needed 1 of the barium hydroxide, and you just plug in and able to get your answer. Now the amphoteric, water is probably the most common amphoteric substance, but any acid that has already given up 1 hydrogen and has 1 more hydrogen it could give up can be amphoteric. If it's a polyatomic that has a hydrogen and it's negative, yes, because it could gain a hydrogen or it could still lose a hydrogen. Okay, so that's what makes amphoteric. What makes a buffer? Basically either a weak acid or a weak base and it's salt. Okay, so we're going to be working with those today. I'm just going to go over this really quickly because it is in part of your stuff. There are some things that you probably ought to look at before you go to the test. They're just little sections in your book about different things. Carbon dioxide in oceans, why is it a concern? That's on page 301 1, and basically carbon dioxide is a problem because we get carbonic acid that decomposes only one hydrogen at a time, and it makes calcium carbonate come out of solution so that the reefs are being degraded, okay, basically. Acid reflux on page 306, and your help, it's about taking Tums and neutralizing the acid, and if you don't, what happens is right here, it's called Barrett's disease, and it actually pulls apart your esophagus and causes holes in it. So, because your esophagus is not made to hold stomach acids. Okay, and does diet play a role in peptic ulcer disease? And that was on page 315, and it's all about sores and ulcers in the stomach and how your stomach acid, once that lining is broken, it starts eating through the layer, mucosa layer, and you get sores, and it's hard to heal it because you need to protect it from the stomach acid. So, and then talks about the food that you can eat. So what I want to do is real quickly go over what we need to do back in lab. I want to make it simple, and what I think I'm going to do is basically we have 2 sets of 4 pairs, and so I'm going to keep you in pairs, just so that you can do the titration quickly, and one of you is inputting, one of you is doing the drop. But you need to know that if they ask you to do a titration at the college to prove that you can do it, you need to be able to do it by yourself. Does that make sense? They might. Like a lab test.
No.
Like the end of the year.
So
Like, are you saying that they have to do it at the end of this year?
Yes.
is that like a high likely?
That is a high likelihood.
You have to take like a show up test, like, oh god,
This year in 1110 you don't have to take the written exam, but they're still talking about having you take a lab practical.
Are they going to be here or are you going to be here?
yeah.
I don't know. That's still up in the air. It will be here. It will be here. You'll be using our equipment. Okay? That is still up in the air. It's still up in the air as far as are they going to do it this year or are they going to wait till next year. I'm pushing to next year, but yeah. Any lab that we have done, you need to be able to do by yourself.
And does that determine, like...
So it's like a final in labs. So it usually counts for twice as much as any lab. Okay, so having said that, when we go back there, just make sure that you know how to do it. Not a big deal. Okay, so what I'm going to do is I'm going to put you in a group of 4. So I'm actually going to have you 2 work together. I'm going to have you work with them. And then I'm going to have you 2 and you 4 work together as a foursome. Okay, so you guys are going to be buffer B, acid, base. You guys are going to be buffer A, acid, base. Okay, up here, you 4 are going to be working. You guys are going to be the weaks on the front. Buffer A, acid, base, Strong's buffer B, acid, base. Okay, so you know what you're doing. Now, if I told you acid, that means you're going to put the acid in the burette. If I told you base, you're going to put the base in the burette. What goes down in the bottom is always the buffer. Okay, so we're going to put the buffer I've already had made up for you. You're going to use your big beaker and go to the buffer and get your 5 milliliters of buffer. Okay, you're going to want to do a quick drop so you can see about how much you're going to need. Okay, or when you need to slow down so you can get a pretty titration curve. And then you're going to go back and set it up again and do 1 more. So you're actually doing 2 titrations, but one's just the quick drop where you don't put the pH meter or anything in it. Okay, so you're going to go back to the south end of the lab on the carts is where your buffers are. So whether I gave you buffer A or buffer B, you're going to go and you're going to get 5 milliliters and there's pumps back there. There are pipette pumps back there. You're going to get 5 milliliters with the pipette pump and put it into your big beaker. Here we're going to want to put an indicator in. and you're going to put in your burette, just like we've done before, if it's acid, you're putting acid in there. If you're base, you're putting base in. Now, if you are acid, this is important. Do not put it in a burette that has the blue around the top of it, the blue tape. Put it in one that doesn't have that. Okay? Because if you put it in one that does have the blue tape around it, you're going to get salt down into that little hole and it's going to clog. Okay? Does that make sense? Okay. So those are down the aisle that the printer is on. So if you're a base, choose the aisle that's not down the printer aisle. Does that make sense? Okay? Or one that doesn't have two burettes. The ones that have two burettes, one's set up as a base, one's set up as an acid. All right? Okay, you're going to titrate it like normal, really fast, quick. Then you're going to do one with the pH probe and the calculators. Anybody remember the program? Easy data. And what do you do once you get into easy data? First you go set up, then events with entry, right? And then you're going to go start. Please don't forget to push start. Okay, and remember you have to hold the keep button until it comes up to where you put the number in. And then go on to the next one. And all the things are the hotkeys underneath. Then you'll come in here and you'll print it. Now, as I was looking through the last labs, you need to make sure when you print for your group, because you're going to make 8 graphs or 9 for this one, okay, you're going to make enough graphs for everybody in your group. You can take and use a snippet tool to snip that graph and put more than one on a page. So we save some paper. Okay? Next year they're actually going to be snipping it and putting it in an electronic document and uploading it to Canvas as part of a formal lab report. So we won't have the lab notebooks anymore, but it'll all be formal lab report. Huh? You hate that? Okay. What I need you to make sure you're doing on your graphs that I saw problems and some of you lost points for. Make sure that I can see what your milliliters are and what your pH is. Okay, some of you didn't widen that column so you could actually see the pH. All you saw was numbers and you had no idea where the decimal was. Okay, so make sure you're widening that. Number 2, make sure that you're doing an interpolate. When you click on the graph, double click on the graph and you're naming the graph, make sure you click interpolate and the point protector. Okay, so you can see the points that you've taken and you can see in between and it will guess in between where you don't have points. Then make sure you go to 7 on your pH scale and write up and off and print. Okay? But make sure you label what you did. I did buffer A with the acid. I did buffer B with the acid. I did buffer A with a base. I did buffer B with a base. So that when everybody gets all their graphs and they're trying to interpret them for doing all the rest of the stuff for this lab, they can do that. Okay, I'm not bringing this lab notebook in until after I come back, so you'll have time to work on all of that. But it'll be coming in right after I come back, and you'll have 3 labs in it. Yes? Your group will need to print off 9. This group will have to print off 8. So everybody gets their own graph. Okay, questions? Okay, if it were me, I would grab a computer and start it up before I went back in the back for my group. Okay, yes? Yes. Okay, let's go get started. Watch your clock.